Hey, geometry students. Today's lesson is actually an algebra lesson masquerading as a geometry lesson. This is going to be something that's very much review. There's going to be nothing groundbreaking here as we talk about ratios, proportions, and I guess the one thing that might be a little bit new is similarity. Although, when we've learned about ratios and proportions in the past, we've learned it in the context of similarity quite a bit. So that's what we're going to be doing today. First of all, we're just going to review some terms. And the first term is, what is a ratio? A ratio is a comparison of two numbers using division. And we actually have three ways of expressing ratios. The first two are not very mathematically useful. The last one is. But all of them are valid ways of stating a ratio. Here they are. We could say the words 1 to 2 for the ratio 1 over 2. 1 to 2. We can use the colon to represent the two, but neither of these are math symbol ways of doing this. Not really. Nothing that we can plug into an equation. Instead, the third way is the most useful and most used way of expressing a ratio, a fraction, 1 over 2. Okay? Now, we use ratios to build proportions. A proportion is an equality statement. It's an equation that states that two ratios are equal to each other. That word equal should signal the word equation. Okay? This is what a proportion looks like. If I have numbers to plug in here, it would be like 1 over 2 equals 3 over 6 or something like that. Usually one of these is a variable. 1 over 2 equals 3 over x. Figure out what x is. This is a proportion because it's two ratios with an equal sign. All right, and then we can define the extremes and means of a proportion. And the way that works, the extremes include the first numerator, the first fraction, and the denominator, the second fraction. This is just called the extremes. The means are the denominator, the first fraction, and the numerator, the second fraction, when we write a proportion. And then we can use that relationship, the means and extremes, to do this. We can solve proportions by finding the cross product. And the cross product works like this. The product of the means is equal to the products of the extremes. So if I do A times D, I could say that A times D is equal to B times C. Now, you may have never referred to these as extremes and means before, but you probably have referred to the process cross multiply and divide. And that's what this is. You do cross multiplication with proportions. We multiply the numerator and denominator, and set those two cross multiplication products equal to each other. And then you can solve for your unknown. You could go through the long method of using the multiplication property of equality on both sides, but that just it results in the same thing as just doing the cross product. So, recommendation to find the cross product. Know the terms extremes and means, although it's not even really important that you know those terms to find a cross product, because chances are you found cross products before without knowing extreme and mean as terms. All right, next. Whoa, all of a sudden we're going to jump from talking about ratios and proportions, talk about similarity. Similar polygons are two polygons that have the exact same shape, but not necessarily the same size. Interestingly, if two polygons do have the exact same size, they're congruent, and we also say, yes, they are similar too. But not all similar polygons have to have the same size. So this would be an example of two similar triangles. These are similar polygons. We notice that when we look at these, they have the same angle measures for all three of their angles. And that's true for similar polygons. Similar polygons have to have congruent corresponding angles. So this angle is congruent to this one, this one to this one, this one to this one. If I have three corresponding angles in the same order in two triangles, they are similar triangles. Now, here's the thing about the sides. The corresponding sides are not congruent. They're proportional to each other. I notice this one's 3 and this one's 6. So this bottom one is double the first one. That means that every one of these has to be double the first one for it to be a similar triangle. And if all three angles are congruent, I know it is similar triangles. So yes, the sides are going to be proportional as well. All right. In finding similarity, we use the concept of ratios to find something called a similarity ratio. It's a ratio of two. Again, that word corresponding comes up. Corresponding linear measures in a pair of similar figures. Now, here's the thing: when I talk about corresponding, I mean sides that we would expect to be related to each other, or angles that we would expect to be related to each other. A and D are corresponding angles that are congruent. We would say that they're congruent angles. But AC and DF, even though they're not the same, they're not congruent, they're still corresponding because we would expect that DF is going to have some relationship to AC because it's in the same part of the triangle between the same two angles. And indeed, it's double. So BC is a corresponding segment to EF and so on. All right, next, I can write out my similarity ratios for all of my corresponding measures. And when I talk about similarity ratios with corresponding polygons, what we're talking about is side lengths, linear measures of side lengths, okay? So I noticed that DE corresponds to AB. I could figure out what the ratio of side lengths is. 6 divided by 3 is 2. EF corresponds to BC. EF is 10, BC is 5. When I divide those two, I get 2. I'm going to get 2 when I divide the last ones as well because they have to be in proportion to each other, and that's what that means. So FD divided by CA is 4 divided by 2, which is 2. Finally, we're going to talk about a similarity statement. This is like a congruence statement. In a congruence statement, when I have two congruent triangles, I have to name the vertices in the same order as each other, like the corresponding vertices in order for me to state that two triangles are congruent. It's the same thing when they're similar, except I have a different symbol for similar. Okay. Remember, congruency was like an equal sign with this little tilde over it. Similarity is just the tilde. What I'm saying here is triangle ABC. Notice I did the 3-line arc A angle, 2 arc angle, and 1 arc angle in that order is similar to D, the 3 arc angle, E, the 2 arc angle, and F, the 1 arc angle. I needed to state those in the correct order to have a correct similarity statement.